Hello, everyone. This is Chetan Dandekar, and today we are going to talk about infrastructure as code on CloudFormation on AWS. Before we begin, just a few items about this presentation. Um, on your screen, you can see a question and answer pod, and you can ask us questions anytime during this presentation. I have David Rocamara, who is going to be the Q&A moderator today, and he will answer the questions throughout the presentation. There will be some time towards the end of this presentation for live Q&A. So he will send some questions to me, and then we can discuss those questions live at the end of this presentation. This webcast is also being recorded. So after the session, we'll send you an email with the URL to the recording as well as the slide deck. So with that, we can get started. This is a deep dive session on infrastructure as code. So I think the audience today is already familiar with most of these terms. I just want to do a quick recap. Chances are you are in a business that needs to differentiate itself, and the way you differentiate is by experimenting and innovating. And while you are innovating, while you are putting new features out there or new solutions for your customers, you also want to reduce the risk in that experiment. That is, if something doesn't work, you want to be able to quickly take it down, or if something works, you want to quickly double down on it. And continuous delivery is a way to support that. It allows you to make incremental changes, test them in the field, and make changes dynamically for things that need to be adjusted. DevOps, the whole DevOps philosophy supports that continuous delivery model through automation, better collaboration, sharing, and measurement of things that you are running in production or in any other environment. And finally, cloud in general and infrastructure as code in particular supports continuous delivery and DevOps, because with infrastructure as code, you can treat the infrastructure that you need just like any other software that you build. Any infrastructure that you need, whether it's compute instances or SQS queues, it's available it's an API call away. So how do you do infrastructure as code on AWS? The flagship service that we have on AWS is called AWS CloudFormation. It allows you to create templates of the infrastructure and applications that you want to run on AWS. These templates are models of the architecture that you want to provision on AWS. It could be a simple machine, or it could be a compute instance and a database and a bunch of queues and so on and so forth. So you pass those templates to the CloudFormation service, and it automatically figures out the API calls it needs to make to provision that infrastructure, the order in which the infrastructure needs to be provisioned. So for example, a database needs to be provisioned before a web server. And it also takes care of any other issues that the provisioning might encounter, like timeouts, the need to retry, dependencies, and so on and so forth. So once you have these templates, you can automate the provisioning of these templates through CloudFormation. You can also treat these templates just like any other code. So you can put them in a version control repository. You can replicate these. You can use the same template in pretty much any AWS account and any AWS region. And like any other software code that you're used to, you can integrate and use these templates with other development tools that you're using. The basic workflow when you're using CloudFormation and you're doing infrastructure as code using CloudFormation is that you have a business problem and you design a solution to that problem. The solution in technical terms is going to have two parts. You will have to design the infrastructure that will run the solution, and then you will have to write or acquire the application code that's going to run on the infrastructure. So you build those infrastructure templates, you build those applications, and then you bring them together to create what we call CloudFormation stacks. These are These are actual infrastructure and provisioned and the actual application bits that are running on the infrastructure. And then you iterate on those stacks. So you might make application improvements, or you might scale up the infrastructure. You might optimize it by doing things like adding an Elasticache cluster and so on and so forth. So that's the basic workflow. And for the next few slides, we'll walk through the details of how to do each of these steps. So let's take an example. Imagine you have an online food ordering service. Then you can think of a solution to that business as a bunch of different services. You might have a food catalog website. There might be an ordering website. There will be a recommendation service based on the type of the customer. There has to be a payment service and so on and so forth. And there are relationships between these services. So these services have dependencies across each other. And each of this service could be a CloudFormation stack. And we'll dive a little deeper into one of these as an example. So let's take food catalog service as an example. So if you want to build a template for the food catalog service, let's see what the food catalog service is going to have. Obviously, it needs to have some security parameter. Typically in AWS, you use a security group for that. You have an application, so obviously you need an EC2 instance to run the application. You want to be able to scale up and scale down based on the need, based on the traffic that you have at any given point. So you need multiple instances, and chances are you're going to use an auto-scaling group to scale up and scale down based on load or time or any other parameter. When you have multiple instances, there has to be a load balancer to route requests to the right web servers. Obviously, there has to be the brain of this whole system, which is the software, the application software that you're writing and hosting on the instances. There are going to be other services that talk to this food catalog website, and then send information to the food catalog website, like information about the customer or the inventory and so on and so forth. So there has to be a way to get that information from those external services into this particular service. You have to publish the URL or the DNS entry for this application for the outside world to reach that application. And then you can do further optimizations like adding an Elasticache cluster to reduce the load on the databases by caching, or adding CloudWatch alarms to ensure that if something goes wrong, then you get an alarm. And all of these things can be modeled in a CloudFormation template. If you were to model all of these resources in a CloudFormation template, this is how your CloudFormation template might look. It's a JSON-based language. And notice that you are declaring the resource that you want to have and the properties of the resource. So for example, for the auto-scaling group, you're saying that you want to have at least one instance at any given time, and at most 3 instances. That auto-scaling group needs to be connected to a load balancer. But notice that you are modeling the resource that you want, but you don't need to worry about the actual API calls that you need to make to provision an auto-scaling group, or the order in which the load balancer or the auto-scaling group needs to be provisioned, and so on and so forth. CloudFormation figures that out for you. And there are several ways to create these templates. You have the option of directly editing this JSON. You also have the option of writing a script in your favorite programming language like Ruby or Python and generating a CloudFormation template. There are several libraries out there which help you in that process. And then there are also a couple of graphical authoring tools which you can use to create these JSON templates. So diving deeper into the anatomy of these templates. To get the information in from outside and dynamically change the nature of the stack that you're provisioning, there is the concept of parameters, the template parameters that you can pass in. So for example, if I'm using the same template in development and in production, in development, I might want to use a cheaper instance. And in production, I might want to use a bigger instance type. So in that case, I don't want to hard code the instance type in my template. I can pass that in as a parameter. Similarly, in development, I might be using a test database, and in production, I want to use an actual production database. So I can pass in that database endpoint as a parameter and then use that in the template. Just like what you would do while writing a software function. There are things which are dynamically configurable, and then you pass those in as parameters rather than hard coding them in the body of that code that you're writing. And when it comes to parameters, we have several things that make it make it more effective and simpler to use these parameters. So for example, if you're passing in passwords, you can specify no echo. So that password won't be visible anywhere once you specify it. You can restrict the set of valid values for a parameter by using things like the allowed values list. And you can also use AWS specific parameter types. So for example, if you're passing in a VPC ID as a parameter, you can specify the parameter type as AWS EC2 VPC ID, and that allows CloudFormation to produce a valid list of VPCs in your account and make sure that the value that is being passed in is one of those values, and that way avoid any provisioning failure that might occur if the value was to were to be invalid. Next, just like you want to pass information in, you need to get information out. In our example specifically, once you provision this web application, the food catalog website, you want to get the public DNS entry or the public IP address out for the rest of the world to consume. And there is a concept of the outputs that you can get out of a stack once you provision the stack. Inside the stack, when you provision those EC2 instances, the next thing you want to do is deploy the application that you want to run on those instances. And we have a framework called AWS CloudFormation Init, which allows you to deploy software on the instances that you're provisioning. And we'll talk a little bit more detail about this feature later in this presentation. And finally, this is a JSON-based language, and to make it simpler to create CloudFormation templates, we provide some utility functions for you. Things like a function for joining a string or selecting an item from a list, getting availability zones, and so on and so forth. So you can take a look at these in our documentation later on. Once you have a template, the next thing you want to do is go and create a stack. This process could be interactive. You could go to the AWS console and create a stack from there, or it could also be automated by running commands via the CLI, the command line interface, or the SDKs or the AWS APIs. Here is a screenshot of the CloudFormation console. You can upload the template, and you specify the parameters, and then CloudFormation goes and creates a stack for you. And then you get a dashboard for the stack or the service that you're running as a CloudFormation stack. And it has things like the outputs that you want to be exposed out of the stack, the events. So if that's a log trail of the order in which the resources got created in the stack, any tags that you might have for things like cost allocation. Another thing to note about infrastructure as code with CloudFormation is that it is not restricted to EC2. When it comes to infrastructure, it's not just compute, storage, and network, but in fact, you can use over 20 AWS services, higher level services like Amazon Redshift, RDS, Elastic Beanstalk, Kinesis, and you can model all of those in CloudFormation templates. So this is the basic workflow that we saw. You design a solution for the problem that you have, and there is the application part of it, there is the infrastructure part of it. You can model both of those in a template, and then you create stacks from those templates. Obviously, everything doesn't end there, right? Once you have something up and running, the next thing you want to do is to improve on it by iterating on it. the way to iterate is just like software, where you code, you version control, you code review, and then you integrate. And then there is, when you want to make a change, you repeat that process again. So you make a code change to the template, you version control it, somebody on your team might review it, and then you go back and integrate that change with whatever you have running. So just to drive the point home, it's all software. Even though it's infrastructure, and there are no racks that you have to lift and shift. It's just a template that you have to code and version control and code review and then integrate with whatever you're running. It also means that all the good software engineering principles that you are familiar with, they apply to the infrastructure as code and specifically to CloudFormation templates. For example, modularization. If there are multiple layers of infrastructure that you're using, you can create separate stacks for each of the layers. So for example, this is what we typically see with our customers. If there is an identity stack, there are a bunch of network stacks, there might be some shared services. So you separate them out into separate CloudFormation stacks. And then there are front-end services which come and go really fast, and they have their own stacks. And once you have this modularization of stacks figured out, then you can easily replicate that in multiple environments, whether it's dev and test and staging environments, or whether it's or it could be multiple regions or multiple AWS accounts that you may have. If you taking this analogy even further, if you think about application software, you write source code, you package that, so you build and package that source code, and then there is some loader and interpreter that ultimately loads that application into the memory of the server that's running the application. And infrastructure as software is kind of similar. You have JSON templates that you either directly create by hand or use a script to generate those templates. And then you pass those to CloudFormation service, which is your loader or interpreter. It interprets the templates and creates the infrastructure that you want in the cloud. We talked about iterating on your template, so let's go into a little more detail on that. So there are two ways to update your stack once you have it. There is in place, and there is a blue-green or side-by-side update of stacks. And let's see what it means. In case of in-place updates, you have an existing template and an existing stack that you created from the template. And let's say you want to make a change. So for example, let's say you want to change the instance type from one type to another in a running stack. You can make that change in a template, and using that updated template, you can call update stack. There is a CloudFormation API called update stack, and you call that API, and CloudFormation will take care of figuring out what's the delta between the old template and the new template, and making that incremental change to your stack. The alternative is to do what we call blue-green deployment. What it means is that you update the template, and instead of touching an existing stack, you just create a new stack from scratch, make sure that stack is healthy, and move the traffic or whatever work your stack is doing to the new stack in a gradual way. And once the new stack is completely operational and tried and tested, then you can get rid of the old stack. And there are pros and cons to both types of updates, in-place update and blue-green deployment. For in-place, obviously it's typically faster, because if your change is incremental, then the in-place update can figure out the precise change that is needed. It doesn't create everything from scratch, so it's typically faster. It's also cost efficient because you're not creating two copies of the same stack. You are just changing an existing stack. And personally, I think it's most important, which is in this method you can simplify the state migration or data migration. So for example, if you have a stack with a database and a web application, and you're changing the web application, by using in-place update, you don't have to touch the database at all. It's just there because it's the exact same stack that you're changing. Whereas if you're doing a blue-green deployment, then you have to think about migrating the database from the old stack to the new stack. There are ways to do it. Typically, our customers would take a snapshot of the database in the old stack and use that snapshot to create a new stack, a new database in the new stack. But obviously, it's more involved. Whereas in case of in-place updates, it's automatic. Going to the blue-green deployments, obviously it has one big advantage, which is at no point you are touching a stack that is working. So there is no possibility that you will mess up an existing and running stack. And if something goes wrong with the new stack, you can almost instantly fall back to the old stack. So you have to. So there are pros and cons to each of these styles, and you have to choose what works best for you. We talked about the broad range of services that CloudFormation supports. It's also worth noting that the use of CloudFormation is not limited to the services that we support. There are ways to extend and use CloudFormation for the service for doing more. There is a plugin system in CloudFormation called Custom Resources, which essentially allows you to write your own resources or own modules within CloudFormation, and then have CloudFormation call those modules at the right point in the stack creation process. Let's see an example. Imagine we are using the same web application that we were building, and now you have this web application up and running, and you want to use a third-party service for tracking the traffic that's going to this web application. Let's say you're using an external web analytics service. Can you model this external resource as part of your CloudFormation template? The answer is yes. You can define a custom resource within your CloudFormation templates. So in this example, I'm defining a web analytics service tracking ID. And you can specify a service token, which is basically an SNS topic, or it could be a Lambda function. And that's the endpoint that CloudFormation will send a message to when it encounters a custom resource. So in the normal course of things, when you give this template to CloudFormation will go on and start creating these regular resources like CloudWatch alarms or elastic load balancers and so on and so forth. And when it encounters this custom resource, it will send a message, a create message to that external endpoint, and whoever is at the receiving end of that endpoint can receive the message, provision the third-party resource, and then send back a message to CloudFormation, whether it's success or failure, and both for the message going from CloudFormation to the third party or the message coming back, you can specify metadata. So in this example, I'm saying, hey, I'm provisioning a web analytics subscription, and I have a goal plan. That's the metadata that's going out to CloudFormation. And then when the message comes back to CloudFormation, there could be things like the tracking ID or any expiration date and so on and so forth that might be relevant in this use case. And then you can use that data that comes into CloudFormation for other resources that you might have in the stack. So these are custom resources which allow you to go beyond the 20 or so AWS services that we support. And recently, in April, we actually made custom resources even simpler by enabling Lambda-backed custom resources. What it means is that you don't have to set up your own web service to build a custom resource. This right side, the custom resource provider that you have doesn't have to be a web service from ground up. It could be as simple as a Lambda function. And there are several use cases where this might make sense. So for example, let's say you have a set of AMI IDs And instead of passing in AMI IDs as a parameter or maintaining mappings within the template, you want to write a quick Lambda function that looks up the right AMI ID for you and then makes that AMI ID available in a CloudFormation template. You can write a Lambda function for that. Or let's say you have a VPC and a subnet setup, and you want to provision all your CloudFormation stacks in the right subnet that is designated for those stacks. In that case, you don't have to explicitly pass in the VPC ID and a subnet ID as a parameter. You can just write a Lambda function that looks up and returns those subnet IDs and VPC IDs when you're provisioning that stack. Changing gears a little bit, and now your ultimate goal is to solve a business problem. So just infrastructure as code by itself is not going to do any good unless you have the application deployment as code to go along with it. And in CloudFormation, you can do both. You can have the infrastructure provisioning part in your templates, and you can also codify the way you want to deploy applications when you are creating the CloudFormation stacks. We talked about the CloudFormation init method, but there are actually several methods of deploying applications in the context of a CloudFormation template, and we'll take a look at all of them. The most basic way is to use an Amazon machine image or an AMI. This could be one of the AMIs that Amazon provides or one of our partners provide, or it could also be an AMI that you built for yourself. An AMI can come with all your application code pre-installed, and you pass in that AMI ID into a CloudFormation template, and then CloudFormation can create a stack with and instances in the stack with using the AMI ID that you pass in. So this is the most basic way. But you could also make it more dynamic and more configurable by using the framework that CloudFormation has called CloudFormation Init. It allows you to specify the application packages you want to install, the users you want to create, the services that you want to start on a EC2 instance, and we'll go into some more detail into that. And it also allows you to bring in any other application configuration tool that you might want to use. So, for example, if you have been using Chef and you want to continue using Chef for application deployment, you can write a CloudFormation template that does the infrastructure provisioning for you, and then have that template install Chef client, and then do the application deployment via Chef. Or if you want to use our newly released service, AWS Code Deploy, you can use the same method. You can provision CloudFormation, you can provision infrastructure using CloudFormation, and then deploy the Code Deploy instance, Code Deploy client, and then let Code Deploy handle the application deployment for you. If you want a more managed and a more interactive experience, you can consider using AWS OpsWorks. You can use CloudFormation and OpsWorks together. We'll look into some more detail into that. OpsWorks in turn uses Chef recipes that are pre-packaged with OpsWorks, or that might be your own Chef recipes. Going deeper into CloudFormation Init, as I mentioned, it's a declarative way of deploying and bootstrapping applications in your CloudFormation stacks. Here is an example. It uses the same JSON that you're used to while creating infrastructure using CloudFormation. You can do things like specifying the list of software packages that you want CloudFormation to install, files that you might want CloudFormation to download, the commands that you might want to run. So, for example, you might have a script that you run for bootstrapping your application, and then you can run that script within the context of CloudFormation Init. Using CloudFormation has several advantages. A, it's declarative, so you just have to tell us the state that you want to be in, rather than actually telling us the fine-grained commands that you need to run to get into that state. For example, if you want to download a few files from an S3 location, you can just tell us the source of those files and where you want us to put the files on your instance. You don't have to worry about authenticating against S3 or figuring out the precise commands or API calls that you have to make to S3 to download those files and copy them onto your. It's also debuggable. You can stream the CloudFormation init logs right back into AWS console. So you don't have to SSH or log on to your instances to see those logs. If something goes wrong, you can debug them in AWS console. It also supports updates. So when you're doing an update stack, and let's say you want to add an extra application package into your template, you can do that, and then there is a CloudFormation daemon running on your machine, and it can detect the change in the set of packages that you want to install, and it will go ahead and install it. As I mentioned earlier, you can bring in any other tool that you might want to use for application deployment. So for example, let's say you are installing WordPress and you already have some chef recipes to install WordPress. You can configure your CloudFormation template to provision the infrastructure and then install chef client, and then bring in the chef recipes that you have for deploying and bootstrapping the WordPress service. Needless to say, all of these operations could be done in an access controlled way. You can use IAM roles, username, passwords, and so on and so forth for securely doing these operations. And going a little more detail, little bit deeper into how to debug these things, we have a service called CloudWatch Logs, which you can use to stream your CloudFormation init logs back to the AWS, back to CloudWatch, and view them in AWS console. There is a little URL at the bottom of the slide which you can click on or use to find out details on how exactly to do this. And finally, a performance tip. There are cases where we have customers who use CloudFormation init or any other tool like Chef to figure out the right application deployment configuration. And once they have figured that out, they want to cut a golden image to make sure that nothing can be changed easily after that point. Or let's say they want to bootstrap hundreds of instances and they want to do it in the shortest possible way. In that case, they bake an army after deploying the software. So in the development and testing stage, they use CloudFormation init and Chef, etc., to deploy applications on top of the instances. They bake an army out of it, and then in production, where they have to create hundreds of instances, they use that pre-baked army, and that way they can be sure that they are using a golden approved and tested image, and it boots in the shortest possible time. An important thing to note from an infrastructure as a code perspective is that if you are baking an army, then you need to make sure that you have some tracking system that can relate that baked army back to your CloudFormation init or Chef configuration. Because an army is going to boot faster, but once it's baked, it will be harder to find out what exactly is installed on the army. Moving on, I mentioned that you can use OpsWorks and CloudFormation together. And let's take a look at why you would want to consider using these two services together and how you use these. So you have infrastructure provisioning and application deployment that you need to do. You can do all of this in CloudFormation, but OpsWorks provides some advantages when it comes to application deployment and management. Number one is that OpsWorks has a built-in application lifecycle. So it has hooks for various events that you can imagine in the life of an application. Installing, initializing, starting, stopping, and so on. So you can hook into these pre-built application lifecycles rather than coding your own coding your own application lifecycle events in CloudFormation init. And second, you have an interactive console in OpsWorks to monitor and to change the life cycle of your application. So, for example, if you want to do patching for your application across a fleet of instances, and you want to have a graphical user interface for that, you can use the OpsWorks console if you deploy your application through OpsWorks. And there are several ways to use OpsWorks and CloudFormation together. One of the patterns that we see is that you use CloudFormation for infrastructure, for provisioning things like IAM, VPC, and databases. But when it comes to managing the EC2 instances and the application on the EC2 instances, you use OpsWorks. Second pattern, this is the OpsWorks and CloudFormation side-by-side pattern. The second pattern is you model everything in a CloudFormation template. So you're modeling your infrastructure in CloudFormation, and you're also modeling OpsWorks building blocks like an OpsWorks stack and an OpsWorks layer and so on and so forth in CloudFormation. And you make one create stack call that provisions everything, the infrastructure pieces of it as well as the OpsWorks pieces of it. This is OpsWorks inside CloudFormation. Moving on, we talked about continuous delivery early on in this presentation, and I just want to share a pattern that we often see among our customers when it comes to using CloudFormation in a CICD context. Typically, there are teams of application developers which are focused on a given business problem, and then there are horizontal teams of infrastructure developers or DevOps engineers who have a broader view, so who take care of the broader company infrastructure or security posture and so on and so forth. So the DevOps engineers or the infrastructure developers create templates that are applicable to the entire company. For example, your entire VPC stack. And the application developers create templates which are more application specific. For example, let's say you're building a product registration application and you're using a DynamoDB table along with it. You can write application code and you can model that DynamoDB table in a template. And those things will live together and will be managed by the application developers. And the basic infrastructure templates will be written and managed by the infrastructure developers. Notice that regardless of whether you are an application developer or an infrastructure developer, it's all software, it's all code, and you're using the same tool chain. You might have an issue tracker, you might be using the same development environment and using this same code repository. And then your software engineering processes also apply for both application and infrastructure. You have code review processes, a continuous integration server like Jenkins or Atlassian Bamboo and so on and so forth. And that server builds application packages, and it also builds the CloudFormation templates that define the stacks that are going to host the application packages. And then the CI server can automatically call AWS CloudFormation service to go and provision the CloudFormation stacks and deploy applications in those stacks using the stuff that it has built, like the application packages and CloudFormation templates. And that can go in any environment, that can be easily repeated in any environment like test or staging or production. And towards the end of this session, I want to introduce you to a tool called CloudFormer. So imagine if you already have a lot of resources in your AWS account, and you want to move from an ad hoc management to the management of those resources via CloudFormation. How CloudFormer is a tool that makes that process simpler. If you already have resources, you can launch this CloudFormer application in your account, and it will help you to walk through all the resources you have, and you can pick and choose the resources that are relevant and create a CloudFormation template from your existing resources. That template is a really good starting point to start templatizing and stackifying the resources that you have in an AWS account. You can further customize that template for things like reusability. For example, if you're parameterizing an auto-scaling group, the template that CloudFormer will produce will have the instance type hard-coded, and you might want to parameterize it so that you can use any instance type with that template. And once you have that template, then you can go back and create any number of stacks from the template that was generated by CloudFormer and customized by you. And lastly, towards the end of this presentation, I just want to highlight the type of customers that use CloudFormation and practice infrastructure as code on AWS. So we talked a lot about DevOps. So obviously, there are developers who value CloudFormation for its ability to treat infrastructure as code, and they appreciate the fact that you can use all the software engineering principles that apply to application to your infrastructure. But there are other type of customers who use infrastructure as code as well. Specifically, if you are an IT admin in an enterprise, you can build a set of CloudFormation templates which are compliant with your company policies, things like security or cost policies, and so on and so forth. And you can prescribe these templates to all the developers in your company. And those templates become your way of making sure that everybody is consuming the AWS resources in a way that is compliant with your company policy. There are also ISVs, or independent software vendors, who use CloudFormation and value that a lot. For if you are an ISV who has an application that you want to be installed in your customer's AWS account, CloudFormation templates become a good way to package the application that you are vending, because once you have a CloudFormation template to deploy your application in your customer's account, it becomes a matter of just a few clicks for your customer to acquire that template and launch a CloudFormation stack that runs the application that you're vending. Even if you are a SaaS ISV, if you're providing software as a service, chances are that you want to scale up as you go on adding customers. And we see some of our SaaS customers use CloudFormation templates, and they go on creating stacks to scale up from the same template as they go on adding customers. So these are different types of customers who use infrastructure as code and CloudFormation on AWS. That's it from me. Thanks a lot for your time, and we'll take a look at a few questions in the